Are you excited for a fun learning session? I am Teacher Lynn, your science teacher for today.
In today's lesson, we are going to talk about concentration of solutions. Do you have any idea what is it, class? Well, let's start. At the end of our lesson, you are expected to have learned the following points. Number 1. Define, differentiate, and distinguish the three types of concentration of solutions. Number 2. Calculate the percentage compositions of solute based on mass, volume, and the combination of both mass and volume in solutions. The importance of knowing the exact degree of concentration of a certain solution cannot be taken lightly. Industry is dependent upon it. Medical science and pharmacology and their associated laboratories cannot operate without it. And even you, without you knowing it, have also been exposed to it at one point or another, especially during the pandemic. One way to identify or to describe the degree of concentration of a solution is by the percent of the solute in a solution. Calculating the exact degrees of concentration of solutions may be derived using several methods, but for our discussion, we shall limit this to 3 methods only. These 3 methods pertain to the percentage amount of the solute in a given solution. Method number 1, mass percent. Number 2, volume percent. Number 3, mass volume percent. Here are examples of the applications of the calculation of percentage concentrations in everyday scenarios. Number 1, an IV fluid of 5% dextrose in aqueous solution. Number 2, 15% solution of ethyl alcohol in water, which is very useful nowadays. And number 3, 20% blend of ethanol gasoline mixture. The next slides will show us the different methods of calculating the amount of concentration of solutions.
The first method shown here is when a solid solute is dissolved in a solid solution in what is termed a solid-solid mixture. Mass is the property used in calculating the percentage concentration, as both are solids and it is more convenient to express the givens in mass, the physical property of weight of any substance. This is the equation to be used in solving mass percent. Here's a sample problem to illustrate mass percent.
Problem number 1. To get the percent mass, you need your solute, which in this case is 25 grams, to be divided by the total mass of the solution's volume. But wait, here's the problem. We don't know yet the total mass of the solution. We are only given with the masses of both the solute and the solvent, and not with the solvent's mass. Remember, no other substance is introduced into the system. Therefore, it is safe to assume that the sum of the masses of both the solute and the solvent is the mass of the solution. That's why we are able to derive our solution's mass, which is 125 grams. Do the math and you will get an answer of 20%. When both the solute and the solution are liquid, it is again convenient to solve for this mixture solution concentration based on its phase after dissolution. In this case, percentage volume is derived by dividing the solute volume by the total volume of the mixture. This is the equation to be used in solving volume percent. And here's a sample problem to illustrate volume percent. Problem number 2. This problem is pretty straightforward
because the mass of the solution's volume is already given. You need only to replace the variables in the equation with the numerical data supplied. Do the math and you will get 16.7% ethanol.
We will now move on to the next equation. This frame explains how mass volume concentration percentage may be calculated. This equation is applicable when solid solutes are dissolved in liquid solutions. The mass volume percent is calculated by dividing the mass of the solute by the volume of the solution and expressing the result as a percent. This is the equation to be used in solving mass volume concentration. Here's a sample problem to illustrate mass volume concentration.
Problem number 3. Take a look at the statement of the problem. If a solution is prepared from 10 grams of NaCl, 10 grams here is the mass of the salt to be dissolved in water to make a 150 ml solution. The final or the total volume of the solution to be mixed is given. That's why this problem is again pretty much straightforward. You need only to replace the variables in the equation with the numerical data supplied. Do the math and you will get 6.7%. That ends our lesson. Thank you so much everyone and happy learning.